Hey Sea Kings, so I'm back. This is example 4. They would like us to graph and solve an equation that has radicals on both sides. So we'll graph it, and hopefully by now you're able to see that this x plus 2 means that the graph is going to be shifted to the left, and this 1 means it's going to be shifted up 1. Also, we don't have a value out here, so that means it's just going to be the regular curve. That's not helpful at all. A regular smooth curve with a starting point, and then it will continue on to the right. Or as x goes to positive infinity, y will go to positive infinity. On this side, notice that the x and the 3 are switched position, so that means that this graph is going to be shifted over, but also that it's going to open to the left instead of to the right. So we'll break these down into, we'll say y1 equals the square root of x plus 2 shifted up 1, and y2 equals the square root of 3 minus x. So for each of these, I'll find the x-intercept, and that happens when we let y equal 0. So for y1, we have 0 equals the square root of x plus 2 plus 1. Shifting the 1 to the left side, it becomes negative. And we will square both sides. Make sure you put the parentheses here to square also that negative sign. So we get 1 equals x plus 2. Subtracting 2, we get negative 1 equals x. So we'll have an x-intercept here of negative 1 comma 0. For the second function, y2, we'll have 0 equals the square root of 3 minus x. Squaring both sides, we get 0 equals 3 minus x, or x equals 3. And that will give us the point 3 comma 0. Okay, for our next step, finding the y-intercept, that means that we have to let x equal 0. So for y1, we'll have the square root of 0 plus 2 plus 1, which is the square root of 2 plus 1, which is approximately, what should that be? 2.4. So we'll say 2.4 there, and that gives us the point 0 comma 2.4. And for our second function, we'll have y2 equals the square root of 3 minus 0. So that's going to be approximately the square root of 3 gives me 1.7. So that gives us the point 0 comma 1.7 for that one. Now these are both square roots, so we'll get one more point each. So for my y1 situation, we had negative 1, 0, and 0, 2.4. If we plug in positive 1, what do we get? That will give us the square root of 3 plus 1, which is 2.73. Or 2.7. So you can see kind of how slowly they grow the most in the beginning, and then it really tapers off and that curve flattens out. So this is y1, this is y2. So we found 0 and 1.7, and here we found 3 and 0. Should we go with 6? 6 won't work. We need, let's go with negative 3. So when I plug in negative 3 here, square, that'll be 3 minus negative 3. So that'll be the square root of 6 is what I'm going to plug into my calculator. So that'll be 2.44. Or we'll say 2.4. Okay. So, getting the graph ready. Let's see what these curves look like and where they cross. It looks like we can go by 1s on both axes, so I'll of course put 2 in the 2 spots. So we have negative 1, 0. We have 0, 2.4. And we have 1, 2.7. So this is our first curve. So even with 3 points, it doesn't seem like it's quite enough information. Let's call this one y1. And with our other graph, we have 0, 1.7, so about here. We have 3, 0, and we have negative 3, 2, 3, 2.4, so right around here. So this is our second graph, our y2 curve. So they definitely cross, but do we know the... boy, this is a great drawing. One of my better works. Okay, so y2. Okay, so they definitely cross right in this area, but do we know exactly what that is from our graph? Not really. Close your eyes. Open your eyes. Okay, so our algebraic solution, we have the square root of x plus 2 plus 1 equals the square root of 3 minus x. Again, we're going to square on both sides, so it's like we're turning this into a line and this also into a line. So maybe we only get one answer, maybe we get two. We are squaring with the square root, so we should expect extraneous solutions to pop up that we have to check. So on this side, when I FOIL this with itself, the first term will leave me with just x plus 2. The middle term will be 1 times this. I'm going to do this out in more detail. Sorry, kings. I feel like this could get confusing if you're multitasking or not. The right side obviously is just 3 minus x, so I think that we're well versed in that. So the first term times the first term simplifies to x plus 2. The first term times the outside term is going to give us 1 times the square root of x plus 2. These middle terms will again give us 1 times the square root of x plus 2. And then the last term gives us 1. So these middle terms all combine, which I think this 2 and this 1 will go to the end as a 3. So we have 2 times the square root of x plus 2 plus 3 equals 3 minus x. Okay, so now I still need to get rid of this square root because there's a variable there. So I'm going to move everything else to the other side. So I'll subtract x here, I'll subtract 3 here. And at that point I have 2 times the square root of x plus 2 equals, the 3's cancel out, negative 2x. I'm going to divide both sides by this coefficient of 2, which leaves me x plus 2 equals negative x. So now I square both sides, and that gives me x plus 2 on the left equals x squared on the right. I'll move everything over and attempt to factor. So x squared, when I move the x, that becomes a negative. When I move the 2, that becomes a negative. And this seems to factor as x minus 2 times x plus 1. Let me double check that. Yep. So that means x equals 2 is a possible answer, and x equals negative 1 is a possible answer. Neither of those really look like our graph, so let's check them both. Maybe they're both extraneous. But it crosses somewhere, so it must work at some point. Okay, so x equals 2. If I pick that, I have the square root of 2 plus 2 plus 1. Does that equal the square root of 3 minus 2? So 2 plus 2 is 4. The square root of 4 is 2. This is 3 equals, 1. That's not true. So that one doesn't work. And then if we try x equals negative 1, which still doesn't seem quite like the location where our graph crosses, but anyways. So we'll have the square root of negative 1 plus 2 plus 1. Does that equal the square root of 3 minus negative 1? So this is square root of 1 plus 1, that's 2. And on this side with the square root of 4, which is also 2. So x equals negative 1 is our answer. And the y-coordinate turns out to be 2. So negative 1, 2. Our graph's not super perfect, but we know when we have to watch for the extraneous solutions, and that's what's really important.